first level, then are we taking the next level? Okay, this question is if threshold value is 0.4 and the support comes as 0.4 for the first level, then are we taking that to the next level in market basket analysis? I think you are asking whether the support threshold value in this case, right? So what I explained threshold in my previous explanation is the threshold value of classification, right? So don't get confused. So here, if we are talking about the support threshold value, and if you have set it to 0.4 and the support comes as 0.4, then are we taking that to the next level? Yes, you can. Because anything greater than or equal to the threshold value can be taken. Therefore, you can consider it for the next level. Right. Then another question is, can you upload this past paper to PDLMS? Yes. Ensemble algorithm, there's another question. Please describe ensemble algorithm. So in ensemble algorithm, what happens is something like this conceptually, right? Now, suppose we want to predict whether it is going to rain tomorrow, right? Now, say I am I have my daughter who is 12 years old, right? So I can ask her whether it is going to rain tomorrow. So she will she has only 12 years of experience, and out of that also she will effectively remember, let's say 5 years back, right? So considering her observations as a 12-year-old and what she has heard and seen, she will tell whether it is going to rain or not. Now, comparatively, I have lived more than 4 decades now. So I can say, I think maybe better than her, if my observations are powerful, sharper than her, I probably will combine it with my experience and I will tell whether it is going to rain tomorrow or not. Now, my daughter has a particular skill set and experience and data and some processing power and a memory. Based on that, she tells whether it is going to rain tomorrow. And I also have a skill set and my memory and my processing power. Plus, I have more experience, right? And I will also tell whether it is going to rain tomorrow or not, right? Now, if I take my mother, she has lived more than 7 decades now. And based on her experience over the past 7+ decades, she will tell whether it is going to rain tomorrow as well. Right? Now take my daughter as a classifier, and I as a classifier, and my mother also as a classifier. And we all are, since we are humans, we more or less share the same structure, right? Same model of classification. Only thing is, due to different parameter values, for example, the length of the duration that we have lived. Right? Based on those different parameter values, I am different from my daughter, right? And I am different from my mother as well. So the same model, but different parameter values, right? And my daughter said one thing, I said another thing, my mother also said another thing. So individually, each one of us are classifiers, right? But say you want to know exactly whether it is going to rain tomorrow or not, right? One option is you go and ask my daughter. The other option is you come and ask me. Third option is you go and ask my mother. Fourth option, you have a fourth option. You are going to take what I say, what my daughter say, and what my mother say, put them together and say my daughter says it's going to rain tomorrow. I also say it's going to rain tomorrow. My mother is also going to say tomorrow. Then definitely you know that it's going to rain tomorrow. But my daughter said not rain tomorrow, but my mother said it's going to rain tomorrow, and I also said it's going to rain tomorrow. Then from the majority's vote, you can say it's going to rain tomorrow. So ensemble methods are like that, right? So you combine, this normally happens in decision trees, right? So you combine multiple decision trees with different parameter values, and you take the outcome of each of those decision trees, and then you take the majority's vote and predict the class. If it is a regression case, you take the individual outcome from each decision tree and take the average of it and predict the value as the predicted value. So that is ensemble algorithms. Okay, wait now. So I think we'll come to this priori algorithm later. Overfitting versus underfitting. Now, overfitting is something like this. Now, when we do predictions, right? When we do predictions, now we have a population to collect the data, right? So data points are coming from the population. Okay, all possible data points that we can collect from this now, but practically you can't get all this data from the population. Right, so because you can't afford, it could be costly, it could be too big, right? It could be not collected, right? So due to various reasons, you can't get the entire population for your analysis. So what you can practically do is to take a sample, right? Take a sample and make a model for this sample, right? Suppose your objective is to find this y with respect to x, right? And these are the points that you have already found out, right? This data point from this sample. Okay. So what you can do is you can create a model, right? Now what you need is a function. So y equal f of x, right? So this function. Let's say this is a parametric function and you try to find this function. No, let's say somehow you need to find this function, right? So function means now you find, now you have how many points? You have, say these 5 data points, right? 5, 4, 6, 7, something. 6, right? So these are those points. So if you want to predict y for different x values, what you can do is you find this function that goes through each and every data points like this, right? So you write, somehow you try to find a function, right? Somehow you try to find a function that goes through each and every data point. Okay. Now this is your machine learning model, right? But when you are trying to use this machine learning model, suppose a new point comes from this, right? New from the population. This is that point. And let me record that point somewhere here, right? Now this point came from this population, but the model has not seen that, right? But you have trained your model very sharply to this sample, right? So the model is very precise. If you take any value that from this sample, it will exactly tell what the outcome is. However, your model is too much trained for the sample, and therefore this new value is unpredictable because this function has no definition for that value. Right? The function has no definition for this value and it will have a bigger error, right? So alternatively, what we do is we say, instead of doing that overly fitting to this data, we maintain some error, but we try to be more flexible, right? So instead of finding this kind of a function, we take a known function like this. We know that there is an error, but we try to minimize that error, right? Through this, what we do is, rather than overly fitting this data to the sample data, we leave a bit of a flexibility here so that any new point can also be accommodated with some reasonable error, right? So that is what we do. So we normally don't try to overfit, we don't try to find a function that exactly describes all the data points very precisely, right? We leave a flexibility here, right? So if you try to train it over and over, so that it finds a function that describes each and every data point precisely in the sample, then we know that there is a risk of getting some new points from the population unpredictable, right? To avoid that, we leave this flexibility. So overfitting is bad, right? So this is what we call overfitting. Underfitting means not training enough, right? So we find a function, but it's not trained enough, right? Say, for example, here out of multiple lines, right? Out of multiple lines, we find the best line, right? Best line means the line that minimizes the possible error. And still we have the flexibility, but this is the best line that describes our sample, right? Underfitting means we don't optimize that. So we have not optimally selected that function, right? So it has not adequately trained, right? So that is what we call underfitting. Let me explain this question. If there are more than two elements in second level a priori algorithm, what should we do? Do we consider three products or do we calculate confidence? In the market basket analysis, if we think we are getting into the third level, what are the rule combinations we can have? Okay. Is there rule combinations correct to test the confidence? Right. There was another question related to that. Yes. All right. So let me do something like this. Now, we have support market basket analysis, right? So we have support and confidence, right? And also lift, right? So, but let's take only these two. Now, in a priori algorithm, only takes or it helps us to find frequent item sets, right? Frequent item sets. So during the a priori algorithm, we only need support, right? We don't need confidence. Okay. So we take, let's say we have 5 items, right? Or let's say 6 items, right? So we, in the first level, in level 1, we find the frequent one item sets, right? Frequent one item sets. Now to do that, we have 6 items now. So we take item 1 as a one item set, right? Item 2 as one item set. Item 3 as one item set, right? Item 4 as one item set. Item 5 as one item set, and item 6 as one item set. Now this using this one item sets, using the a priori algorithm and support, we can find which ones are frequent. For that, you need a threshold, right? Let's say you put threshold as 30% or 40% or whatever. That is the acceptable support threshold for you to say that a particular item set is a frequent item set or not, right? Let's say from our algorithm, we found that I1, I3, I4, and I5. These are frequent and these two are not frequent, right? So now we don't carry this item 2 and item 6 to the next level, but we are going to make 2 item sets using the existing one item sets, right? So level 2 is then frequent 2 item sets, right? So how do you do that? Can combine I1 with I3, right? I1 with I4, I1 with I5, right? Then I3 with I4, I3 with I5, right? I4 with I5. So these are the 2 item sets. Then again, you can compute their support values and compare it with the threshold, and whatever above the threshold value you can take, right? Let's say you get I1, I3, this one is frequent, this one is frequent, and let's say let's again say this one is frequent, right? So I1 and the other ones are not frequent, right? So I1, I3, I1, I4, I3, I4, right? So these are frequent. So from this, we can consider further. So level 3, right? Level 3 is frequent 3-item sets, right? Frequent 3-item sets. So what are the frequent 3-item sets? I1, comma, I4, comma, I5, right? I5, I4 is here, right? So I3, I4, so I3, right? I3. So I1, I3 is here, I1, I4 is here, I3, I4 is here, right? So you can say I1, I4, I3. So this is the only frequent 3-item set that we can define according to my example. Suppose this is the support value is 45%. So this is also acceptable. If this is only 30% and if your selected threshold is 40%, then we can't take this, right? Then we have to go back to this one, and that is our only, we only have frequent 2-item sets. Then we can define rules as if I1, then I3, if I3, then I1, right? If I1, then I4, if I4, then I1, and if I3, then I4, and if I4, then I3. These are the rules that I can choose. Now, when you are having this one, now you can define the rules the way you like, right? So you can, let's say you select this one as a frequent item set, then there's no need to look at the IL2. From this, you can define certain rules, right? For example, if I1, then I4, right? That is one rule, okay? If I1, then I3, another one, right? Another one would be if I1 and I4, then I3. This is another rule, right? If I1, then I4, I3, and I4. This is another rule, okay? So you are free, right? You are free to select the rules like this, okay? So what's important is whether you select the confidence right, so that you take the rules selected as effectively as possible, right? So constructing these rules can be done like this. So the last question of Shayan, if A, then B, right? And if A, then if the third level. Now, first of all, the way you have written this item set is wrong, right? For example, if we think we are getting into the third level, A arrow, B arrow, C. This is not the right way, right? Use the curly brackets, A, comma, B, comma, C. That means A, B, and C are frequent, right? Then it is a frequent, if it is a frequent item set, then you can think of rules, right? Then your rule selection is also wrong. So if A, then B, then C, no, that is not the case, right? So association rules means if something, then something, right? So in your case, you have 3 components with 2 arrows. That is the wrong representation. What you can do is you can say if A, then B, right? If A, then B and C. If A and B, then C. So likewise, you can write. Okay. So this way of writing is wrong. I hope it is clear now with my example. Right. I think I answered all your questions. Right. What else can we do? Let me check the questions. What's the time now? Second question. a charitable organization, this is, I think, yeah, now you know this context, right? So a charitable organization has over 1 million registered members who fund for various social service activities. They have the demographic and behavioral data related to all members, including their donations during the past few years. Expecting to raise funds for this year, the charity plans to contact its membership over the phone and request donations. However, due to the high call cost, the charity wants to optimize its return from this calling project by carefully selecting the right members to call. The organization thinks that this could be done using data analytics as they have past few years data. Suppose you are hired as a data scientist for this project, right? Now, you know this case, right? So now it means that in an exam, you can test whether the students are able to apply what they have learned to solve a problem, right? So say you go to the industry as a data scientist, nobody will tell you, nobody will ask you to apply a logistic regression model to a particular problem, right? That kind of request will never come. So what you get would be the business problems, right? You get business problems and you will have to solve those business problems with the help of data analytics and machine learning. So that is what you are supposed to do. Then you should be able to map what is required to the problem at hand, right? So you should select, okay, should I use unsupervised learning or should I use supervised learning? Am I going to use clustering first or am I going to use classification? Am I going to use classification or am I going to use regression, right? So you must choose, right, as appropriate for the problem. So I am testing that ability through this question. So explain how, the first question is, explain how data analytics can help the charity to meet its objective. Right now, to answer this question, you should understand the requirement of the charity and you should be able to map the different types of analytics into this problem. Right? For example, you should be able to say, okay, we can use predictive analytics so that we can predict who is likely to donate, and also not only who is likely to donate, but also how much each likely donor is going to donate. So predicting who is going to donate is a classification problem, whereas predicting how much is each likely donor is going to donate is a regression problem. Right? So that is question number 1. Second question, is it going to be supervised or unsupervised machine learning that you are going to use in this project? Explain your standpoint with reasons. And my second question, right? So supervised or unsupervised machine learning. Then you should know what is supervised machine learning and what is unsupervised machine learning. So unsupervised machine learning is generally clustering and supervised machine learning is generally regression and classification. So definitely, since this is more suited for this is more like a predictive analytics project, we are going to use supervised machine learning. Then briefly describe a potential machine learning algorithm that you would use in this project, right? So I'm testing whether you know some algorithms, right? You can even simply say, I'm going to use k-nearest neighbor algorithm, right? K-nearest neighbor is a potential supervised machine learning algorithm. It is non-parametric algorithm because we are not trying to fit a known function into the data. There, what we do is we are trying to, our function is we take the some number of nearest neighbors and based on their actual values, we are going to predict the actual value of the new subject. So you can even say k-nearest neighbor algorithm in this case because it's accepted as a potential machine learning algorithm for classification and regression. So other algorithms that you have learned like decision trees or neural networks, you can mention those things. Name 5 important features that you wish to have in the charity's data set in order to use the algorithm above, right? Briefly explain the reasons why you think that those features are important. Say, now here what I'm trying to get from you is whether you can think in terms of a context. For example, what would make somebody donate, right? What kind of features would make somebody donate? Age, for example, right? When you're getting older, are you ready to donate? Your income, right? So if your income is high, then you have more disposable income. So would you consider donating something to a charity, right, from your disposable income? Then your gender, right? So who is like to donate more? Like, is it males or females, right? So some sort of a reasonable thinking about this required features is what I am expecting as the answer here. Do you think that K-fold cross-validation is important in this exercise? Explain why. So you must remember what K-fold cross-validation is. I think I explained this to you when I'm talking about this orange tool. So K-fold cross-validation is, now what is cross-validation? Your data set will be split into training data and test data. So your model will be trained using trained data and then tested on the test data. That is cross-validation. That is validation, right? So cross-validation means now you divide your data set into, let's say, five portions or K number of portions, and you take you leave one portion out as the test data set, and you the remaining K minus 1 portions will be taken as the training data, right? In the first iteration. In the second iteration, you take a portion which was there in the training data set in the previous iteration as the test data set, and you take the previous test data set into the training data set, right? So interchangeably you do that. I think I explained how the K-fold cross-validation happens in the last or previous, the lecture before the last lecture. So you can go through that again and understand what is K-fold cross-validation is. So obviously K-fold cross-validation is going to improve the model because you get the opportunity to expose more data to your model, right? However, the K-fold, so now if it depends, it might depend on the amount of data you have as well. For example, since you have 1 million donors, if you can take all 1 million or let's say 500,000 data, then it's a big number. Then of course K-fold cross-validation may not be that important, right? Because you have enough data. So usually this cross-validation is required like when you have smaller amounts of data, and if you leave aside say 20% of the data as test data, you remain with even lesser amounts of data. So then your training will not be that effective, right? So cross-validation could be like applied when you don't have enough data, so that all data points could become training data as well as test data, right? But I think in this case, if you have enough data, then perhaps going for K-fold cross-validation is not important. But yet, having said that, it will give the opportunity to expose more data points to the model so that the outcome of the model will be better, right? So K-fold cross-validation is important in this exercise. The question number 3 is about predictive analytics and ID3 algorithm. What is the use of confusion metrics in machine learning applications to evaluate the performance of a particular classifier mainly? Briefly describe the key information measures that can be obtained from the confusion metrics using a diagram of a confusion matrix. What I am expecting is something like this. I don't want all these, but having this is enough, right? So sensitivity, specificity, negative predictive value, precision, and accuracy. You must also have an idea why this accuracy alone is not sufficient to explain the goodness of a particular classifier. Why do you need these additional measures for that, right? So that is expected. Consider the following data set of a computer store on customers buying a particular model of laptop computers. Suppose you are going to use the ID3 algorithm to build a decision tree to predict whether a customer would buy a laptop of that model or not. Answer the following questions based on this table. Compute the initial entropy of this data set. So you must remember the entropy formula and the way of computing the initial entropy. Define the term information gain and compute the information gain for the feature frequency of buying. So frequency of buying has three values: frequent, moderate. Here there's a typo, right? So frequent, moderate, and rare, right? Those three types. Then initial entropy should be computed for the entire thing. Then you are going to split the table according to these values. So those values which are getting frequent will be one sub table. Those who are with moderate will be another sub table, and those who are with rare will be another sub table, right? So then for each sub table, the entropy will be computed and aggregated as the after split entropy. Then the initial entropy minus the after split entropy will give you the information gain, right? So that process you must understand. Suppose you are going to use an artificial neural network to predict if a customer would buy or not buy a product. Pre-process this data set as appropriate and present the revised table. So if you closely look at this data set, you can see that all these columns are having categorical data, right? So a neural network cannot take categorical data in because it has a aggregation function inside the neuron, right? So therefore, all this data will have to be transformed into numerical data. So how to transform a categorical data into a numerical data would be required, right? Your understanding on that would be required. So frequency of buying is having three values. When you transform this into numerical data, then you will have to add three new columns. One for frequent, another one for moderate, and the other one for rare. So it's like what we call 1 hot encoding. It is not now. If you look at this data, they are actually ordinal. So frequent, moderate, rare, high, normal, right? Weak, strong. So strong and weak. So because of that, label encoding is also okay, because when you say weak equal 1 and strong equal 2, right? Then it implies an order, right? So that's not wrong. So high and normal, that is also like that. Normal is lower than high, right? So if you put 1 as normal and 2 as high, then it indicates that order. Frequent, moderate, rare, that is also like that. So we can say rare equal 1, moderate equal 2, frequent equal 3, right? So since there is an order, there's no issue of using label encoding as well. It need not to be one hot encoding always. So, but however, you have to convert this into numerical data. Question number 4, association rule mining is a descriptive analytics technique. Do you agree with this statement? Justify your answer. So I would agree, because it describes, right? So existence of association rules can be described using association rule mining. So in that sense, it's a descriptive analytic technique. Briefly describe what is meant by support and confidence in association rule mining. So you can find the formulas and define accordingly. Briefly explain two uses of association rule mining. For example, designing bundle offers is one thing. Planning the layouts of supermarkets is another thing, right? So these are examples. Consider the following transaction data set of a clothing store. Find an association rule using a support threshold of 0.2 and confidence threshold of 0.7. Clearly state your workings, right? So this is, you need to go through that priori algorithm and then find the frequent item sets. And then accordingly, you must see whether you are going to get a association rule or not. Right, that's more or less my answers to this question paper. So what I'm going to do is I'm going to convert this into PDF, and I'm going to upload this to PGLMS after the class. Right after the class, I'm going to upload this. You can go through the answers I gave and can prepare for these kind of questions. So the paper will be more or less same, but I have the right of changing the structure as well, but I have no plans to deviate drastically from this pattern, but there could be a slight change to question number 1, right? Other than that, we more or less same. Okay. All right. So the recording will be uploaded to the PGLMS as well, right? Right. That's it. Okay. So I'll see you at the exam on 4th, and wish you good luck. Right. See you on the 4th. Good night.
Thank you very much.
Recording stopped.